Good afternoon, everybody. I welcome you all to my channel on basic chemistry. Today's topic is hybridization part 3 on VSEPR theory. This is VSEPR theory. VSEPR. It is pronounced as VSEPR. VSEPR. The spelling of the word is VSEPR, but it is pronounced as VSEPR. Its full form is valence shell electron pair repulsion. This VSEPR, its full form is valence shell electron pair repulsion theory, and this theory says lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion. This VSEPR theory says lone pair repulsion. I shall describe the details. Lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion, and in the abbreviated form LP greater than LP BP greater than BP. This is lone pair in the abbreviated form greater than lone pair bond pair greater than bond pair. Now question arises, what is this lone pair and what is this bond pair? Lone pair means one electron is having two electrons or a pair of electrons, one in the upward spin, the other one in the downward spin. One moving in the clockwise direction, the other moving in the anti-clockwise direction. We call it lone pair. In another case, when one electron is there, only one electron is there, it is non-bonded and it attracts another electron for its bonding. We call it bond pair. Two electrons are there, it is lone pair. Only one electron is there, it is called bond pair. This bond pair electron is always in need of another electron for its bonding. Now, this will be more clear when I shall tell you the examples. Now, I shall tell you here 3 examples: methane, ammonia and water. In case of methane, the formula is CH4. Here the central atom is carbon. Its atomic number is 6. and its electronic configuration is 1s2, 2s2, 2p2. In the box-like structure, applying Horn's rule of maximum multiplicity, the structure is like this: 1s2, 2s2, because s orbital is non-divided and p orbital is threefold degenerated. This is 1s2, 2s2, 2px1, 2py1 and 2pz0. Here, two non-bonding electrons are there. It should form compounds by getting two electrons from two different atoms, like compounds CH2, CCl2 can be formed. But what happens? Actually it forms CH4 and CCl4. How it is possible? It forms compounds CH4 and CCl4. So how it is possible? What happens? This is the electronic structure in the ground state. And in the excited state, this is a different orbit. This is the first shell. This is the valence shell. In the valence shell, one electron from 2s will jump over to pz by bringing the structure. Here there is one. Two s1, 2px1, 2py1, 2pz1. In the ground state, it has two unpaired electrons. As it forms compounds like CH4 and CCl4, that can be explained only that in the excited state, one electron from 2s will be shifted to 2pz, bringing the structure to 2s1, 2px1, 2py1, 2pz1. All are in the same energy level, so they can take part in the process of hybridization. Now, how many orbitals from s orbital? Only one. So I shall write 1s plus. How many orbitals from p? 3p. It will give rise to 4 sp3, or we can write 1s plus 3p will give rise to 4 sp3. This means it forms hybridization sp3. I have told you before, in case of sp3 hybridization, when the hybridization is sp3, its bond angle is 109.280 degree or 109.5 degree, and the shape is tetrahedral or regular tetrahedral. I do not want to draw its figure because my portion is VSEPR theory, and that will be more clear in the shape of ammonia and water. So whenever the hybridization is sp3, this is the bond angle and this is the shape. Now what happens in case of ammonia? Here the central atom is nitrogen. Its atom number is 7. Electronic configuration is 1s2, 2s2, 2p3. Applying the same Horn's rule for maximum multiplicity in the box-like structure, the electronic configuration both in the ground state and excited state are as follows. 1s2, let us forget R point is on the valence shell, 2s2, 2px1, 2py1, 2pz1. This is the valence shell. It has 4 orbitals, 2s2, 2px1, 2py1 and 2pz1. These 4 orbitals, 2s2, 2px1, 2py1 and 2pz1, they will take part in the process of hybridization as they are in the same energy level. Now, out of the 4 sp3 hybrid orbitals, how did 4? 1s, this is 1, this is 3, so 3p, it will give rise to 4 sp3. Now, out of the 4 sp3 hybrid orbitals, one is having lone pair, the other is having single electrons. They are called as bond pairs. Lone pairs will remain as it is. Bond pair electrons, they will attract electrons from outside atom to form bond. Now, as it is sp3 hybridization, in case of ammonia, as it is sp3, the angle should have been 109.28 degree or 109.5 degree. But applying VSEPR theory here, because we have a lone pair of electrons, VSEPR theory will be applied and angle is reduced to 107. And the shape should have been tetrahedral, but it changes to, because applying VSEPR theory, it changes to distorted tetrahedral. And it is called trigonal pyramidal. Trigonal pyramidal. In case of ammonia, the hybridization is sp3. Angle should have been 109.28 degree or 109.5 degree. But because of the presence of lone pair of electrons, VSEPR theory will be applied here. Lone pair, let me tell you, lone pair, bond pair, and what else is there? This is nitrogen here. It is sp3 hybridized. sp3, 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 sp3. 4 sp3 hybrid orbitals are there. One is having lone pair of electrons. The other three are having bond pairs. I shall write it here as a lone pair, LP. This is BP, bond pair. This is BP. This is BP. Lone pair, only one lone pair is there. So in VSEPR theory, lone pair repulsion will not exist here. And lone pair bond pair repulsion, this one, lone pair bond pair repulsion, lone pair of bond pair repulsion is greater than bond pair repulsion. Lone pair bond pair repulsion, lone pair bond pair repulsion is greater than bond pair and bond pair repulsion. So it will repel from the upper side and the angle is reduced to 107 degree. And the shape is, this is nitrogen, this is the shape. It is a trigonal pyramidal. Trigon, this is the line structure, this is the orbital structure. It is, shape is trigonal or triangular pyramidal. Instead of tetrahedral, the shape changes to trigonal pyramidal. Angle is 107 degree instead of becoming 109.28 degree. And hybridization is sp3. This is about ammonia. Now the last one, shape of water I shall tell you. In case of water, the central atom is oxygen. It is atom number 8. Electronic configuration is 1s2, 2s2, 2p4. Applying the same Horn's rule of maximum multiplicity, the structure of electrons, the arrangement of electrons, both in the ground state and in the excited state, are as follows. 1s2, 2s2, this is 2p x2, 2p y1, 2p z1, this is 2s2. These are in the valence shell. 2 are having lone pair and one is, the other 2 are having bond pair. So here VSEPR theory will be applied. Let me tell you. Here 2 electrons are there. This is lone pair. Here 2 electrons are there. This is lone pair. Here 1 electron is there. This is bond pair. Here 1 electron is there. This is bond pair. Now lone pair repulsion. This one. Lone pair repulsion. Lone pair repulsion is greater than lone pair bond pair repulsion. lone pair, bond pair repulsion. Is greater than bond pair repulsion. Is it clear? We have the total VSEPR theory here. Lone pair repulsion is greater than lone pair bond pair repulsion. Lone pair bond repulsion is greater than bond pair repulsion. And the angle changes from 109.280 degree to or 109.5 degree. It changes to 105 degree or 104.5 degree. And the shape, instead of becoming tetrahedral, it is V-shaped. And this is possible by applying VSEPR theory. I hope it is clear to you all. And also I hope you like my teaching about VSEPR theory. Thank you all. Thank you.